Hello and welcome to this edition of the Rule Breakers podcast. I am delighted to welcome Tim Bray um, onto this episode, and we're going to take a trip down memory lane of all things related to documents and computers and the ability to search documents and the ability to mark structure up in documents and so on. And there are a few people on the planet, I think, um, who have the breadth of experience and knowledge and expertise that Tim has on that subject. So I'm really, really delighted to have you on to speak with me today, Tim.
Delighted to be here.
When did it first dawn on you that there were interesting things that could be done in computers with large volumes of text? I think you and I are, I guess, from maybe a similar age. I think you're a couple of years older than me, um, but certainly back when I was first exposed to computers, like the main function of the big computers was to do things with databases, tables of data. And I distinctly remember it being uh, a new thing when someone said, "Oh, and someone has invented a clever way of just being able to search large volumes of text with computers." Would this have been around the time that you started out in Digital Equipment Corporation? Was it before you founded OpenText?
Well, I graduated in 1981
Hmm.
and immediately got a job with Digital Equipment, which at that time was the world's second largest computer company. And it was a pretty interesting job. Its biggest downside was that it was in Toronto, which has really brutal weather, and I didn't feel in harmony with. So I got a job with a telephone company R&D lab and was, building T1 multiplexing systems and things like that. And in 1987, everything changed because I saw an ad for the Oxford English Dictionary Project at the University of Waterloo, and they had some money from IBM and the Government of Canada to work on the Oxford English Dictionary OED problem. And they had a condition of the money was they not only do research, but they write software that could do useful things with the dictionary. And so they needed to hire a professional programmer to run that. So I became the manager of the new OED R&D team in 1987. And when they first showed me the OED text, for those of you of our listeners who don't know that much about big dictionaries, the OED is the largest one ever created for the English language, and it is a scholarly publication, it's a descriptive lexicology, lexicography, which means that it doesn't try and say how the language should be used, it is how the language is used, and
Is
thus
he?
each entry is accompanied by banks of quotations from literature illustrating the use of the language. In any case, so they popped the text up on the computer screen before me, and there were these tags. I'd never seen tags before, these angle bracketed things saying, okay, the entry starts here, and here's the actual word, and then here's its etymology, and here's its pronunciation, and here's the first meaning, and here's the sub-meaning, and here's the bank of quotations, and each quotation has a date and an author and a text, and so on and so forth. And all the lights went on in my brain, and I thought, well, why isn't all the text in the world done this way?
Right.
Because it became instantly obvious that if people wanted to work interactively with this very rich data source and also use it as a book, you had to have this. You had to have
Mhm.
the ability to display it on the screen in one way and print it on the page in another. So the OED was 572 megabytes, if I recall correctly, of tagged text. And it was trying to be SGML, but it wasn't. But as a consequence of that, I learned about SGML and what it was. And I thought, well, okay, this is a standardized way to write down what we're doing with a dictionary. And except for SGML was so hard and so persnickety and had included all these features that were really, really hard to understand. And there was a notable lack of consensus about which of the features should be used and which shouldn't. And that consensus extended to the software, where some software supported one subset of features and other software supported other subsets. So in 1990, so we founded the company OpenText, and I went to work there. And our big claim to fame was that we had search software and interactive document manipulation software that could handle nested structures in the style of SGML
Hmm.
and eventually XML. And we didn't let it bother us if it wasn't exactly well formed and some of the tags didn't quite have matching begin and end tags, and there were some overlaps and so on, but it was still immensely useful. And so the company was quite successful, um, largely, I think, due to the fact that when the web suddenly started to become ubiquitous in the early 1990s, we had software that could deal with tag text and do intelligent things and give alternate renderings and, do search on combinations of inclusions and exceptions and so on in various structures. So the company did pretty well. And I eventually left in 1996. And just at that time was when John Bozak had decided that it was really important to take the good parts of SGML and throw away the rest aggressively
Mhm.
and write that down as a standard. And so he came along, and I had been visible at some of the web conferences and the SGML conferences, and talking about simpler approaches and general utility of tag text, and asked me, do I want to play in this new project he was doing? And so some point in the first half of 1996, they spun up the XML working group, and I joined it. And well, that's how it all started.
That's how it all started, right? And you mentioned it was quasi. It was angle brackets. Was it the people who had put those angle brackets into the original OED text? Had they been aware of SGML and just not followed it to the letter, as it were, or did they just happen to stumble upon the idea of using angle brackets to
Um,
indicate
yes, they
structure?
were aware. The way it was actually done was that it was typed in by low paid people in Florida, and it took I think it's something like 100 and something person years of work to do it, if you add it all up, and it was all done double entry. And they had so as to a very effective technique for catching errors, and they had a fancy editor that ran on IBM 3270 block mode terminals for typing this stuff into, because IBM was one of the funders. And they were trying to create, properly nested HTML style structures. They had their own syntax for entities, but it was, close enough. Um, and in fact, it turns out that the dictionary, in fact, had structural errors in it all over the place because it originally had been written by human beings. And so what they got was, I think, a good, accurate representation of what was actually in the dictionary, but it was not all that cleanly structured. But more
Right.
than enough to be useful. And that was really the takeaway lesson, is that you don't have to be perfect in the HTML style to have actually highly usable stuff.
Oh, indeed, yeah, indeed. So that would have been 1987. So SGML became a standard, I think, in 1986.
I believe that's true. Yes. Mhm.
I think I first came across it, I think, in 1985. Dr. David Abramson in Trinity College Dublin was using it to teach us programmers. We wanted to learn how to write our own version of Pascal or to write our own compiler. But the project that Dr. Abramson decided to use the year that I was there was was SGML. So much to the disappointment, I think, of some of the programmers. But I always found it fascinating that it was, as you know, there are tools like YAC, are like there are things for compiling compilers, but they're typically things that you do first, and then it spits something out, and then you use that thing to parse a document or a
Right.
program, computer program, same thing. I was always intrigued by the idea that although HTML was very complicated, it did this really, really interesting thing that it was all done dynamically. It started, you give it a description of the grammar, which it then figures out, and then it uses that grammar then to go, and work on your document. I thought that was a really, really cool idea. But I remember being bitten over and over again over the years by the complexity of all of the various ways you could get yourself into trouble with SGML. Um, with things like inclusion exceptions, I remember, and
Oh, gosh.
yeah, I remember interoperability always being, something of an issue as well. Like when the thing started to explode, and tools started to come along, it was great to see that there were tools, but I always found it was never as easy as, hey, here's my SGML document, work with it. Um, Oh, was it Wayne Wohler, was it in IBM, who came up with the phrase monastic XML or monastic SGML? Or maybe that was you. Did you
No,
know?
I don't think that was me. I remember that phrase, and yeah, let me tell you a funny story about the weird features. So about halfway through at the point at the time I was working on XML, I had left OpenText, so I was an independent consultant working for anybody who would hire me. And I got a call from this software company in Belgium. Um, and they wanted me to come over and give them some advice on this hot new XML stuff that everybody was going to be using. And so, sure, yeah, they bought a few days of my time, and so I went over there, and we started talking. And they had a contract with the European Union to structure the legislation of the EU, which is obviously a good application of tag text. And the conversation was weird. And it turned out, I discovered only a couple of hours in, they couldn't hide it. What they had done was in structuring the EU legislation, they had used SGML's notoriously obscure concur feature. And
Oh, okay.
and so their real goal in hiring me was to convince me that I should go back and convince the XML committee that we should include concur in XML so that they would be able
In
to
the XML
preserve their
spec.
investment in the EU legislation project. So that kind of thing went
Right,
on.
right. Right. Yeah, 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 yeah. I can imagine. I mean, I'm guessing that a lot of the folks. I mean, I came along in that in the um, John Bozak asked me to if I'd be interested in getting involved, just on that emailing list, the special interest group. But I'm guessing that when you initially sat around and started looking at the everyone's ideas of how this thing could be simplified. I'm guessing there was a fair amount of overlap. That there were some features that were like obvious to most folks that they're perhaps surplus to requirements. Um,
My memory of that period. So XML was defined, most of it in this first ferociously intense sprint between, I don't know, May or June of 1996, and then SGML 1996, which was the conference in November, if I recall correctly, or December, sometime like that, where we announced the work. And we found consensus very easy on
right,
almost everything. Um, the set of tools, the set of features that were going to be discarded or left behind was really not that hard to
right.
so it helped, the OpenText had been working with this stuff without there being a definition. So had Steve DeRosa's company. What was that called? EBT,
Um,
electronic
ABT,
book.
electronic
And they
book,
had
right.
Dynatext, I think it was called.
Mhm.
And they had quite a bit of commercial success using that as well. So, we had people in the room who had actually done it and, had educated opinions.
Right.
But I, we had ferocious debates, but they were about things like parameter entities and,
Boom.
and things like that, which were off in the corners to some degree. And the whole project was done and frozen by February 1998, which is
Right.
insanely fast for
Right.
a
Right.
major standards project.
Right, indeed. I remember a piece of very good theatre from James Clark. Maybe it was at, I probably was at that conference in 1996. Was that Boston, was it?
It
I
was
can't
at Boston. I
remember.
remember that well.
But James had, I have a picture in my head that it was a blue cover. It was the draft XML spec.
I think you're thinking about something I did.
Oh,
Um,
okay.
which was as we went around, around the circle talking about what we were doing. In those days, we felt that things wouldn't be taken seriously instead if you didn't print them out. So we
Right.
had these printouts of the draft XML spec, which
Yeah.
was, only 30 or 40 pages long. It
Right.
wasn't
I
very, very
remember it.
big. It was a very slender document. And
Yeah.
so as I was speaking, I took two or three instances of this thing and spun them out
That was
over the
you. Okay.
audience and remarked that if I'd done that with the SGML spec, there might have been fatalities.
Right, you would have taken out the first three rows or something. I think you said it was, yeah, yeah. I remember that distinctly. Yeah, that was a really interesting moment in history looking back on it. Now, it felt like it was some sort of inflection point as well. I would have to say it's not one of those, looking back on it now, that was an important moment. It felt like an important moment as it was happening. I remember it was standing room only. Uh,
It was a big room too.
yeah, yeah,
And I remember the atmosphere being just electric.
right, yeah, yeah, yeah,
And I have to say, we did that, and it went over, seemed to go over quite well. And we were expecting ferocious resistance from the SGML traditionalists, and basically got none.
Right.
And then, John Bosak and I and a couple of other people thought, well, how are we going to go and sell this thing to the world? And we went and tried to get on the stage at all the conferences and so on. And, it was
Right.
like pulling your weight against the door that turns out not even to be latched.
Right. Right.
You looked at it, I said, oh, yeah, I could use that. And it all happened just unbelievably fast.
And I remember you being at the time, being a strong proponent of the introduction of Unicode into the whole thing, and Unicode being actually a really big part of the whole thing. Was there much? But was that also an open door thing, or was there debate around the use of Unicode?
Um, that was an open door. And, looking back in the rearview mirror, I think I would say that one of the most important consequences of XML is that it carried the Unicode along with it. A lot of
Right.
people who said, this looks like a good thing that we could use. Oh, that means you're going to have to use Unicode. Well, I guess we should anyhow. So a lot of people did.
Mm,
And there were, the Unicode, just like SGML has lots of corner cases and little weirdnesses.
mm,
And by an odd coincidence, I have a draft RFC going through the IETF right at the moment, which has been approved and will become get an RFC number sometime in the next few weeks, um, which actually points out that in the million or so code points that that Unicode offers, there are some you really shouldn't use.
right.
And those include the surrogates and a lot of the control characters. And then there are codes that are explicitly marked as non-characters, and you should stay away from those. Um, and in that document, we provide some predefined subsets that you might want to consider looking. One of
Mm,
them is just what they call the Unicode scalars, which excludes only the surrogates. The second one is the XML characters, because the definition of
right.
a character in XML has worked out really well over the years.
Mm.
It excludes a lot of the bad stuff, not all. And really, I think that's marked a stake in the ground that has worked out pretty well.
Right, right, right. And you got involved in JSON as well from a standardization perspective, didn't you?
Yes, well, I got interested in the IETF. I found that, the I'm happy to put a small proportion of my work into standards. Uh,
Mm,
I wouldn't want to be a full-time standards warrior. And I found the process and the atmosphere of the IETF quite a bit more congenial
mm,
than at W3C. So I've been doing some things over the years in IETF, and there was not actually a very good definition of a specification for JSON. There had been an early RFC for it, but it was informational as opposed to standards track,
right,
which means it's difficult to cite it and so on. So they said, okay, we really need to clean that up, and so we did RFC 8259, which is the standard. Which is the specification of JSON that everybody uses.
right,
Then we did another one called iJSON, I-JSON, which is kind of like XML is to HTML. It excludes some of the stupid things that JSON allows. For example, JSON does not forbid duplicate keys in objects, and
right,
JSON allows Unicode surrogates and things like that. And so iJSON is just a somewhat slimmed down version that is also doing
right,
well.
right, right. It's been interesting to watch how, I remember in the early days of XML, like most things, I guess, people sometimes overshoot, you get silver bullet syndrome, all of a sudden everything looks like an XML problem. And along comes JSON, and it's arguably a much better fit for some certain types of, especially kind of tabular type record centric, data. How do you think that, do you think that the balance that we've ended up with now is about right, or has it skewed badly one way or the other?
I don't know. XML has clearly found its place in certain domains.
Yeah,
Legislation being, a major one. Humanities documents are another. Um, Large technical manuals, like for aircraft maintenance manuals and so on, are another. And there's really no sane argument for using JSON in those things. And if
Right.
I'm writing an API to, I don't know, uh, a database or to a financial record system or something like that, there's no sane argument for using XML. JSON is
Right.
better. One could regret that JSON is so totally frozen. You couldn't possibly change JSON at this point because there's just a few little things that would make it so much richer, like timestamps and some mathematical types and so on, arithmetic types and so on. But I think the it's it's about okay. And there's a lot of people using Markdown for documents these days,
Right.
and there's TOML and YAML
Yeah.
and CBOR and so on. So people have not given up on inventing new packaging formats, and I guess that's mostly okay. But there's a lot of XML out there. Um, in fact, there are, as far as I know, the world's most popular messaging application is WhatsApp and XML. All those billions per day, probably billions per hour these days, of WhatsApp messages have XML inside. If you actually look at the wire
I did
form.
not know that. Right.
Not only that, not only is the data format XML, but the software is Erlang under the covers.
Erlang. Yeah, yeah. That bit I remember hearing that all right about the use of Erlang. That's got all the way back to Ericsson, doesn't it, for telephone
Indeed,
switches?
it does indeed.
Yeah, uh, yeah, that's really interesting. Uh, the you mentioned Markdown. I was going to ask you specifically about Markdown actually because it's obviously it's been around for quite a while, but I have noticed an uptick in interest in Markdown because it's popping up in some of these AI tools. Um, so, for example, some of the stuff that I've seen that's doing, say, PDF data extraction and attempting to reverse engineer from the visuals of the document hierarchical information about what's in the PDF. A bunch of them generate Markdown. Um, so we seem to be on the cusp, I think, of maybe Markdown becoming one of maybe the big three in terms of like the syntaxes that are out there for representing structured data in plain text form. But it certainly
Well,
surprised me when I just found how prevalent the use of Markdown was in the large language models in particular.
Well, my main technology activity these days is working on ActivityPub in the Fediverse and building a conversational social network that isn't owned by anybody and is decentralized and federated, and
Right,
be a bit more like email and little bit less like Facebook. Um,
right,
and at the moment, this tends to be somewhat Twitter-like, although it supports long form as well, and without formatting at all. And people who are talking about introducing formatting are all talking about introducing Markdown. And
right,
so when John Gruber thought up Markdown, he says that he was just trying to make it easier to write down HTML.
right, right,
And
right.
from the point of view of people who just want to style a few paragraphs of text, Markdown has everything you need, right? You want
Right,
bold
right.
italics, you want hyperlinks, you want paragraphs, sure, you can't do tables, but that's okay, right? You can't do JavaScript craziness, which is actually
Hmm,
probably good.
probably good.
So I think for entry level text styling, Markdown has a bright future. And you can actually ask people to write Markdown just at a keyboard without help, which you really can't do with HTML. Um, so yeah, I think it's just fine.
Right, right. And there seems to be the tooling seems to be coming along as well. I mean, even some of these outlining tools and pour your thoughts into the computer things that generate little nodes connected to other nodes and so on. A bunch of those seem to favor markdown type syntax as well.
And
Um,
GitHub has been tremendously influential.
oh yeah,
GitHub sort of decided at some point, long before I ever became aware of it, that every project will have a readme.md.
read me to
And
MD,
and
right?
and the formatting is perfectly okay. It's everything you need to introduce a software project kind of thing. I noticed that Markdown is really well equipped for styling code.
Right,
Um,
right, right, right. Yeah, yeah.
and so it's going to be with us for the long haul.
Yeah, yeah, I think so. I think so. Um, so and then after, after, so you set up, it was textuality, wasn't it? Was that, and then Antarctica, wasn't that another company that you started along the road?
Right. Antarctica unfortunately did not succeed. Most startups don't. So my batting average with I'm using North American metaphor here. My batting average with startups is 1 for 2,
Okay.
which is that's okay. And Antarctica wasn't XML based at all. It was a data
Right,
visualization company.
right.
Um, so after doing that, I fell into the world of big tech and worked in
Well,
succession for Sun and Google and AWS.
right, right, right. I remember at one stage, actually, you invited me over. Thank you very much. To I remember the California at one stage for a conversation about Jython, the Java implementation on the JVM. Do you remember that?
I don't.
Yeah,
Joy-Con. What was
uh, uh,
Joy-Con?
Jython, J Y
Oh,
T
Jython.
H
Oh,
O.
yes, yes. Now I remember that. Yes, yes. Sun hired me. They were declining, and I was part of a move to see if we could save Sun, and the move failed. Oh well. But Sun was, they had this attitude was, hello, pleased to meet you. Java is the answer. Now, what was your question?
Right,
Um,
right, right,
and when I joined Sun, they were so insular. They didn't actually realize that things like Facebook and Wikipedia weren't written in Java. They said, well, they must be. They're big systems. Well, no, they're not.
right,
Um,
right,
and so then we became very interested, or I got them very interested in more mainstream things like Ruby and Python and so on. Well, would Java be an attractive platform to run those things on?
mm,
And the answer has been sometimes yes. I often know Python goes from strength to strength these days.
right,
It is clearly, the dominant language of AI and of data science in general, and of, in fact, scientific programming in
right,
general,
right, right, right,
and lots of other domains as well.
right. I mean, if memory serves, um, in the room that day when I was there anyway, there was Larry Wall was there talking about Perl,
Yeah,
and
we had very well. We had Guido too. We had Guido van
Guido van
Rossum.
Rossum was there. Yeah, yeah.
We had the groovy people. Groovy was,
Groovy
the
people, I remember
language.
that. Yeah, yeah,
We had the
yeah.
Groovy people and Ruby, and we didn't have Mats, but we had some other Ruby people. Um,
But I guess
yeah.
there's still lots and lots of Java out there in the plumbing.
Well, there's still lots and lots of COBOL out there, Sean, in the
Right,
plumbing.
right, right,
You can't use a Visa card without executing some COBOL in a back room somewhere.
right,
So,
right.
and Java has its well-known failings,
Yeah,
but it's still okay, and it's actually really fast. Modern JVMs are very high performance programs, and I worked at Sun, and well, Sun of course, but at both Google and AWS. A high proportion of the backend infrastructure is written in Java, and things like
right,
the Google search engine and they don't know about that. A lot of the Google identity infrastructure, and a lot of the major AWS services are written in Java, and nobody's ever going to rewrite them.
right, 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 right. And were you in Sun? I can't remember now when you did. Was it Lark? Was it the one of the early validating XML parsers? That was in Java, wasn't it?
That was in Java. That was how I learned Java. That was before I joined Sun. And
Okay.
the name of that was funny. There's a story to that because what happened was in November of 1996, I got married to Lauren Wood, whom you know,
Lauren, yeah,
and
I know. Yep.
we went to Melbourne to do that because that's where her family was, and so we were married in Melbourne. And the day after our wedding, Lauren fell and seriously damaged her knee, her right knee. And so we spent uh, a couple of weeks, where she couldn't walk, right? And so we just hung around at her parents' place in Melbourne, and I wrote the world's first XML parser, sitting on the sofa there.
Right.
And LARK stands for Lauren's right knee, LARK.
Oh, I didn't know. No, that is news to me. Oh,
And
that's great.
that leads to
Oh, that's
another point,
great.
which was, I wasn't the only person doing that. James, of course, was working on his own parser, and Microsoft was building one, and
Oh,
IBM was building one. And that's why I eventually abandoned Lark. There was all these other people with more money than me, working on their own. But one of the big lessons of XML is that it's not the first genuinely interoperable data format. ASN.1 is, but
mm,
ASN.1 never really became ubiquitous or widely used. And the reason for that is there was no open source software. If you wanted to use
right.
ASN.1, you had to buy an expensive, flaky, buggy, slow, ASN.1 parser and rely on that. And uh, uh, before XML was even frozen, there was Lark, there was the Microsoft parser, there was at least one other, and they were all pretty
Mm,
good and pretty fast and free. And I think that really, really, really made a huge difference in how XML was accepted.
right, right, right. It's interesting. I mean, you talk about how in the IETF process kind of appeals to you. If memory serves, their slogan is something like, is it rough consensus and running code? Is that something, a phrase they use in the IETF?
That's correct,
Uh,
yes.
do you think that rough consensus and running code, um, does that avoid, I guess HTML is an example of great big thing, uh, clearly valuable, uh, clearly has too many moving parts, and then 10 years later someone creates a subset and then the subset takes off. I think the same thing happened with, directory services. Was it X400 or X500 or something?
Right.
No one uses that anymore, but everyone uses son of X500, which is LDAP. Do you
Right.
think that the rough consensus and running code thing is a way to avoid that, great big monster, 10 years later, useful subset?
Sadly, no. The IETF has
Okay.
its share of massively overcomplicated arcade and Baroque. I mean, DNS, for example. To understand DNS, there are something like 14 different RFCs that cover different parts of it. Uh,
Okay.
and everybody knows that if you were going to do DNS from scratch, you wouldn't. You just use HTTP and it would work fine. And in fact, there is a project DOH of DNS over HTTP, which I don't know. The DNS is so deeply embedded in everything that I don't suppose it'll be replaced. But no, there seems to be something intrinsic in standards that uh, um, encourages completism. And we had a certain
Right.
amount of fighting about that. I mean, Michael Spurgeon McQueen and I did the vast
Everyone remain, no?
majority of the work of actually writing the spec. And my joke was that, I wrote 40% and Michael wrote 80%. And then, I convinced him to discard, a third of what he wrote, and it all worked out. And for example, and XML schema is an example of something that did not have a minimalist in the room.
Right.
And as a result, it became way more baroque and complicated than it needs to be. And
Right.
same thing's happening in JSON. There's a thing called JSON schema, which is the basis of the OpenAI spec, not an Open API spec,
Mm,
which is fairly widely used, but it's a really bad piece of work, and it's just overly complicated
right.
and way too many moving parts, as you put it. And as a result, there are multiple alternative JSON schema, lowercase schema, schemas for JSON
Right.
proposals floating around, all of which are dramatically simpler. So
Right.
yeah,
Right.
I
Right.
like the ITF process, but it doesn't protect you from that.
Okay. All right. I do I do sense that we're on the cusp of yet another scramble of these, like MCP, for example, is an acronym that's now, being thrown around,
Right.
um, in the AI world. Do you think, but I don't see anyone so far. I haven't seen anyone set up a consortium in a big American university to marshal the whole thing. I remember that happened with X11, the graphical standard back in the day. I think that was also MIT, which is where the W3C ended up.
Right.
Um, do you think now would be a good time for people to start, trying to take some of that stuff, like say, agent interoperability or so on, from AI land, and do something with it, or let it run for a while until things start to calm down a bit.
It's difficult to talk about this stuff because of the distorting influence of too much money.
Yeah.
Um, I actually published a blog piece earlier this week that it got on Y Combinator and was read by tens of thousands of people. And my basic argument was that there's just too much money. There are $306 billion invested in startups only for around Gen AI, generative AI. And then, Google says they're going to spend $75 billion a year building AI-oriented infrastructure. And McKinsey says, the total build out over the next 5 years is going to be $7 trillion. Yeah, who's going to pay for all this? Where's the money going to come from? Um, and, the future could be, Sam Altman is right about everything, and everything everywhere will be done by AI, and nobody will actually write code. We'll all just vibe code, and so that's one possible outcome. The other possible outcome is a crash where almost everybody goes bankrupt. We could have a replay of the 2000.com crash, where everything that had internet in its name had money thrown at it, and most of them went bankrupt. There were a lot of pets.coms and so on out there.
Hmm.
But what was left over actually turned out to be pretty useful.
Right,
So
right,
one
right.
could hope that would happen. But any attempt, I think, to standardize at this point is I certainly wouldn't get involved.
Yeah, 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 yeah. It's incredibly volatile. I mean, some of the stuff I find, I have to say, I know you're very concerned, and I share your concerns about the stuff that's generally not talked about, which is, well, gee, if all of the world's power grid is going to be used to crank these things, then what are the rest of us going to do? Us, us normal humans, as opposed to the AI agents. Uh, and when I hear things like big tech companies getting licenses to run their own nuclear reactors, that kind of stuff gives me pause. But I have to say, some of the stuff I've seen in the document world, I found just really intriguing. I mean, the Google Notebook LM thing in particular, I thought was really interesting. That idea that I could actually I could listen to a two-person conversation where they're talking about a document that I uploaded, um, and then I could interrupt them and ask them questions about what they're talking about. In other words, that my document could actually become a podcast episode. My document could become it's no longer me, it's me and two other people, and the three of us are having a conversation about what's in the document. That kind of reframed my notion of what a document could be. Um, have you had any of those moments with the AI stuff that you've seen?
Um, I have a problem. I have a visceral sort of fear and loathing of the whole technology. Part of that, to be honest, is I'm a strong environmentalist.
Right. Yeah.
I have been arrested for sitting down in front of a pipeline that I thought was a stupid idea.
Right.
Um, and I just look at the gigawattage requirements to drive the
Mm,
model building and so on, and I think that that we can't afford that.
right.
The world my children have to live in, we're wrecking it, and we can't do that. Um, so it is my profound hope that the predictions are overblown. Um, I don't use a vibe coding conversational agent to help me write code, but I do
Mm,
notice that the autocomplete in the code that I do write is really getting a lot smarter.
right. Right.
I use JetBrains, and I was running through this great big body of code. I had a horrible, horrible bug putting in print statements to show me what was going on, and after a while, it was writing them. I would say, okay, I'm gonna put them here. It said, yeah, print out the value. So that kind of thing. Who could object to that?
Right. Right.
That's
Right.
great. No, I've not personally had any delightful experiences
Okay.
with. I've had fun going to the image generators. Uh,
Mm,
I once asked to make a picture of a basketball game between a death metal band and a bunch of folkies, and it was so funny I just about fell out of my chair laughing at it. But
Right.
okay, fine.
Right.
But can we afford the wattage? Can we afford the power for that kind of thing?
Yeah,
Um, at the moment, I observe that there are a certain number of professional software people whose judgment I respect and whose integrity I think is, well established, who are
mm,
reporting positive experiences, and that's enough for me to
right,
conclude that there is a there, that
right,
there
right, right.
is some benefit to be had. Having said that, boy, when I noted that in my most recent blog piece, I got ferocious pushback. There is a very large
Okay.
uh, faction of people in our profession, I would say maybe a majority, who really think the people who like it are fooling themselves. And in fact, the one quantitative study I have seen, which was published by Rachel Stevens of RedMonk, no, it was
Mm,
reported by Rachel Stevens of RedMonk, which actually evaluated the productivity and uh, quality of work, done with and without Gen AI support, did not find support for the notion that it actually produced a measurably positive result.
right,
So I think we have to agree that the jury is out on that.
right, 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 right. I mean, I've noticed the same with the autocomplete. The uh, one of the things that I recently saw when I was using one of those, when I was vibe coding, that seems to be the cool phrase now, but uh, has been added to the English language. When I was vibe coding some Python, um, so it auto completed something for some Python library for me, which I then tried to run and it wouldn't got a runtime error. Um, and but it was because that library has changed since the model was trained.
Right.
So that idea that it has a lot of understanding of what the entire world's text looked like maybe 2 years ago. Um, that seems to be me to be a significant issue that we're going to have to find a way to work around.
There
Uh,
was a very interesting story published by Steve Klabnik, who's a well-known person out of the Ruby community and now working for Oxide Computer. And he reported on trying to get to vibe code the CSS for his blog, and
mm,
had exactly the same problem. Is that he was using a newer version of the CSS libraries and the model knew about, and so it all broke down. Then he was working on an assembler and trying to generate ELF binaries for Linux, and it
mm,
works amazingly well. Well, that's been
right,
stable for 25 years, right? And
right,
so
right, 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 right. Uh, in fact, I think what's the gentleman's name who came up with the phrase vibe coding? I'm forgetting his name now. I think, but if I'm right, it's the same person who came up with this one-liner that the cool programming language in the 21st century is English. Do you know the person I'm talking about?
I do not know who that is, but we'll see. I mean, but Sean, let me think. In 1985, I was reading like Datamation and Computer World, and they were saying, oh, well, we're almost to the point where business leaders can just tell the computer what they want and
Right,
it'll put to them. So that claim is hardly new, and
right.
Um, so I in particular, I used to write Android apps,
Mm,
and Android has this huge API and quite good API, but a huge API with hundreds of classes and thousands of methods on it and so on. And they've done a good job about having sort of uniform idioms across that. And I was doing that full time for years, and I couldn't remember all that stuff. When I
right.
wanted to make a call out to the vibrator, to vibrate the phone kind of thing,
Mm,
who can remember the API for that, right? Well, an AI could probably
right, right,
could generate that call for me. So I think that the kind of coding where you're, just connecting complicated APIs to other complicated APIs, you're probably going to get, really a lot of help from that. The codes that I'm
right.
currently working on is a finite automaton implementation, where you try
Mm,
and, merge finite automata together so that you can get the OR of a large number of
mm,
them. And that's really just shuffling bytes around in tables. And I wouldn't expect to get too much help from that because that's, core algorithms work that, is not done that often. So
right.
anybody who claims they know where we're going to be in 2 years is just full of it.
Yeah,
It's a
yeah, yeah, yeah.
moving target.
It is incredible. Yeah, it's moving incredibly fast. But and I've never seen anything like it. As you say, in terms of the velocity of money through it, um, I've never seen, even inflation adjusted, it's still the most insane allocation of capital I've ever seen in the since I got involved in all of this stuff back in the 80s. Um,
I haven't dived deep, but I went and spent less than a full week, but a few days just diving into the matrix algebra that they use, what they do with what they call a transform and how they represent documents and so on. And it's not rocket science. It's reasonably straightforward. And it's not that hard to understand what these things are doing. It is hard to understand why it is that those operations lead to such plausibly reasonable outputs.
right,
But
right.
but it's baffling and a little bit saddening that a relatively simple mechanic can lead to such plausible imitations of you and me.
Right, 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 right. And another a one-liner I saw recently that I really liked was someone made the comment that they didn't think they'd see the day when computers would be bad at math and good at English. Uh, this is that's been a really interesting inversion to watch as well.
Mhm.
Um, but I guess it's definitely changing the concept of our people's notions of what it is to be information in a computer. Certainly, I think we probably reached peak PDF at this point. Um, I think the number of people who are looking at information, um, you know, and starting to think past the PDF, I think is definitely uh, going upwards, and I think that's a good thing.
Yeah, I mean, I think, I've made peace with PDF as a delivery vehicle.
Mm,
Um, and it works well for that. I was recently an expert witness for hire in a very, very large litigation with, thousands of pages of documents, and everything was a PDF.
mm.
And that was okay. It's a good way to, consume a lot of information fast. But, I would think that Gen AI ought to work well with like legislation that's encoded in XML, for example.
Well,
Um,
absolutely.
because it's full of repeating patterns and formalized restricted vocabularies within the
Right.
formalized restricted structure. So I would suspect that it would find good use there, except for the tolerance for errors and hallucinations in the legal domain
Exactly.
is very, very low.
Very low indeed. Yeah, indeed, indeed. But no, you're right. And what lawyers for the longest time have carried around in their heads and sometimes, verbalized as a citation graph, um, is the consensus at the moment seems to be that that is key to getting good results out of these things is to get yourself a knowledge graph and use RAG or some similar technique to point it at some sort of ground truth, to reduce at least if it's citing back your sources, at least you can go and fact check it. It may well be the thing that it's cross-referencing, um, may exist and be a thing, but it might still be a hallucination, arguably. But at least you have some scope for being able to fact check what the AI has done.
You
Um,
know, as I suggested, and go and dig into how the transformations work and all the matrix algebra they do.
Right.
Um, the question for somebody like me is, well, how would you modify this to keep it from having hallucinations?
Right,
And it's really not obvious
right,
because
right.
it's at the end of the day, it's simply statistics,
Yeah,
computing very sophisticated, mind you, statistical structures to say which word is next most likely to occur. Uh, and as far as I know, nobody has really hooked up a generative API to a model of the actual real world and the facts in it. And as far as I
right,
know, I don't hear much talk about how you would go about doing that. So
right, right, right.
I'm not sure how that's going to work out.
Yeah, yeah, same here, same here. I mean, I do wonder if in a few years' time, um, you know, do you think it's possible that there'd be some major algorithmic breakthrough, which basically, significantly reduces the computational effort involved in training one of these things, or do you think that's just the way it is, laws of physics and all of that.
Oh, absolutely. It already has. I mean, there was that Chinese company, DeepSeek, that
Right,
built what seems to be a pretty good model at like 1/10 the cost. I
right,
mean, you know how it is with software. You get it to work, and after you've got it to work, you start to think about optimizing it, right? And I think
right,
everybody in the industry is still focusing on getting it to do more ambitious stuff, and relatively few people are working on how to optimize it. And I think there's got to be better ways than optimizing it than feeding it to hyper expensive, uh,
right,
specialized chips from NVIDIA.
right, right, right. I did recently get access to Google Diffusion, which is taking that miraculous, audio video, diffusion technique, based on, adding noise, and working backwards from noise towards something useful, um, and applying that to the world of textual material. And and the main benefit seems to be that it's just way, way, way faster in terms of its if the, no, I don't know if there's any major benefits in terms of the training costs, but the cost per query or the cost per prompt goes down a lot, because this thing is responds way, way faster than, word for word, statistical calculations. But it's all really interesting. It's a very interesting time to be watching this. I'm glad I'm at a certain age though, where because it's I've always really enjoyed the fact that, every few years, the world of computing, would have a revolution, and I'd have to go and learn a whole bunch of new stuff and burn a whole bunch of more midnight oil and stay up on weekends and working on things to
Yes.
keep up to date. It's nice for once just to be standing at the top of the hill watching what's going on, rather than being in the trenches actually
Mhm.
trying to create some of this stuff, because it's a lot of it's changing so fast. Um, but isn't it amazing to think that, things like, as you say, XML inside WhatsApp, you know, Markdown, arguably, as you say, popularized by GitHub, now becoming, a really important part of this new infrastructure. Um, a bunch of the RFC standards that, drive everything from email to, gosh, a whole bunch of things. There's definitely uh that percentage of your time that you put into standards is time well spent, isn't it? Because the world does have the ability to go through these revolutions, and yet if you peel off the layers, some foundational stuff that was standardized X number of years ago um has a way of living forever. Not everything, obviously. I know you're a musician as well, aren't you? Do you play anything
Amateur,
with
of
it?
course. Nobody has ever thought of paying me a penny for performance, but I actually I'm going out twice a week these days to participate in regular musical events. So.
Cool. Playing what? What do you play?
Well, I played cello for 25 years and
Right.
I've abandoned that. And these days I play drums and in particular African flavored and Afro-Cuban music.
Right.
And so djembe, which is the very
Djembe.
large
Yeah, yeah.
African drum, and some congas and claves and
Yeah, yeah.
bells and things like that.
Very, very cool. But as you know, like in that world, there's this thing called MIDI,
Yes.
which is this 8-bit standard. I don't know when MIDI was standardized. That's a long, long, long time ago. And yet a whole bunch of, everything from, the light shows and, huge big concerts to strapping together, keyboards and things, and drum machines and so on. It's all, if you peel off the layers inside it, there's this itsy, teeny weeny little MIDI specification. It's probably one of the most successful standards in the digital world, actually. Um, so it just intrigues me that standards are born every minute, and there's the attrition rate is high. But some standards have that ability to really get baked into the infrastructure and be there for the long haul. As you mentioned earlier on, we still live in a world where COBOL COBOL runs a whole bunch of stuff. So we just never can know, I guess, what parts of this are going to really make it.
Indeed.
Uh, on the On the document side of on the idea of documents and digital documents, do you see any major gaps or things that really need to be done? Or do you think between all of the various things we have now, the rough consensus and running code that we have around, say JSON on one end and XML on the other and Markdown and so on, is there anything screaming in your brain that really needs to be looked at, or are we kind of done with that layer, for want of a better word?
Well, as I mentioned earlier, it would be nice if JSON were a little bit smarter.
Right,
Um, just having timestamps and some numeric types and so on would be very, very beneficial, but it's never going to happen. People have
right,
learned how to work around it, and that's okay, I
right,
guess. Um, I really don't perceive any hunger for anything that's missing.
right,
Uh, and the good thing is, and here's, another major contribution we should not forget of XML is, prior to, 1996 to 1998 when XML came along, there really was not an interoperable data format that worked across operating systems, across programming languages, across databases, and so on. And that's astonishing that we got to 1998 without having that. I mean,
right,
ASN.1 was trying, but it was always a feeble contender. And so I think everybody now buys into the idea that you should expect any data format to simply as a basic entry level uh, criterion to be operating system independent and programming
right,
language independent. And given that that's not controversial anymore, I don't really perceive too much in the way of open problems that need to be
right,
solved. Now, obviously, the whole AI domain, as we were talking about, could change that. I mean, is it going to end up the case that MCP is going to need to something like MCP or whatever replaces it is going to need to have new kinds of constructs that are not available in either XML or JSON or something? Seems
right,
unlikely, but who knows what could happen.
right, right. I guess the candidate that's kind of going through my mind is, all the stuff that Tim Berners-Lee, did related to the semantic web. Um, there's lots of talk about Sparkle and SCOS and Turtle and all of these different ways of representing an operating system and programming language independent way of representing triple stores, I guess, or graphs. Obviously, there's an awful lot of interest around graphs at the moment. Um, that
Well, interestingly, in ActivityPub, which is the protocol behind the Fediverse, Mastodon, on, um, there's some JSON LD in there,
Okay,
um, which is interesting. This is one area in which Tim Berners-Lee and I were never able to really come to a meeting of minds.
right,
Um, the great problem with triples is that where do they come from? They're freaking expensive to create, and they really resist automatic extraction from data. So yeah, it would be a much better world if every document information resource identified where it sits in some grand ontology. Um,
mm,
but that's not the world we live in. So
mm,
I own the domain name rdf.net. I bought it when I was
okay,
actually on the original RDF working group, and I've offered it for free
okay,
to anybody who builds a semantic web linked data RDF application that I would actually use every day. And I first made that offer in 1998, I think, or something like that, or maybe 2000. Um, and I'm still in it. I haven't given it away. So that's just not a direction
okay,
that I'm very positive on.
okay. All right. Really interesting. Really interesting. Really interesting. Well, Tim, it's been really, really fun talking to you. Um,
Indeed.
uh,
We look
it,
back too rarely.
indeed, indeed, we absolutely do, and life goes by very quickly. So, thank you very much for taking the time to talk to me today.